Okay, so in the last class that we did, we learned how to balance compounds based on like their charges. We had a cation and we had an anion, and we learned how to balance it based on, you know, the charges of those ions. Okay, so this is what we did. Let me go up to this is what we did. Remember, we looked at sodium. Sodium is Na. Sodium is in group 1, therefore has a plus 1 charge. Nitrogen is in group 15, therefore has a minus 3 charge. So we had to like multiply sodium by 3 so that we match up the negative 3 charge. Plus 1 times 3 is plus 3. Plus 3 minus 3 cancel out. And here is your compound. The multiple becomes your subscript, right? Lithium was plus 1 because lithium was in group 1, and oxygen was minus 2 because oxygen is in group 16. And plus 1 times 2 gives us plus 2. So Li2O is our compound because plus 2 and minus 2 cancel out. Okay, so today we're going to be going a little bit further and learning how to name your ionic compounds. Okay, so the just one second for me to just check if I'm recording. Okay. All right. So here's how you name your ionic compounds. It's really simple. Okay. The name of the cation would just stay the same as the name of the element. Okay. Remember, we always write the cation first. Cations are positive, remember? And then the second thing we write is the anion. Okay, so from our example in class, here is a compound. The first thing you're going to encounter is always the cation. Okay, so let me just change this color so we can color coordinate. The black one is the cation. Okay, so here's what you do. Cation name stays the same name as the element, so Na is just sodium. So all you have to write is just sodium. Okay? If you have some kind of transition metal, meaning from the D block in your periodic table, we know that the ion charge of those transition metals can vary. So because of that, if you have a compound with a transition metal, you have to actually figure out what charge the ion has, and that charge becomes a Roman numeral in the compound. Okay, for example, if I have this compound, okay, Fe2 O3. That means I have two iron atoms and three oxygen atoms, right? We know from our charge balancing and our annotation of the periodic table that oxygen coming from group 16 has a charge of minus 2, right? We know that oxygen has a charge of minus 2. So there are three oxygens, each carrying a charge of minus 2. So if I were to physically draw this out, here are my oxygen atoms. There's a charge of minus 2, O2 minus, O2 minus, O2 minus. This is what it means to have three oxygen atoms, right? So this is that, three oxygen atoms, right? So in order for us to have negative 2, negative 2, negative 2, when you add that up, we get a negative 6, right? We know the charge of oxygen is negative 2 because when we look at our periodic table, the charge of oxygen is negative 2. We wrote that down in our periodic table. So I have three oxygens, each with a negative 2 charge, adding up to a total of a negative 6 charge. Now, what I have here is two iron atoms, right? Fe Fe. Iron is a transition metal. So, if you look at the back of your periodic table, here's the back of your periodic table, you'll notice that there is iron 2 right there, and there's also iron 3. So we have to figure out which iron is it that is forming this compound. So here's how you figure it out. If you have a negative 6, we know for a fact that in order to balance out the negative 6, I need a plus 6. If I have a plus 6, I have to distribute the plus 6 equally to these two atoms. And the only way I can do that is if I give each iron atom a plus 3 charge. Okay, so plus 3 gives me 6. We can't have 3 iron atoms because the subscript tells us there's only 2. So the 2 has to hold the total of the plus 6 charge. So each of them must be a plus 3. So if it's iron plus 3, then you can get the name of the ion. It's iron 3. Okay, ion is iron 3. So when I'm writing the name of this compound, I would say this is iron Roman numeral 3. This is iron 3. I will teach you how to name the anion part of the compound in just a second. Okay, so the cation for a regular atom that is found in the front of the periodic table, meaning anything in group 1, let's see, group 1 is plus 1, right? Group 2 is plus 2, group 13 is plus 3. Anything from here, you can just write the name of the element, like magnesium or calcium or strontium or rubidium or potassium. You just write it like that. But if you find the element here, the transition metals like iron, you have to flip to the back of the periodic table, find the two versions. There's iron 2 plus and iron 3 plus. Then you look at your compound, you find the charge of the anion. Anion you already know because oxygen is in group 16, oxygen is negative 2. So oxygen is negative 2, there's 3 oxygens. That is a total of a negative 6 charge. That means the left side, the cation side, must be a total of plus 6. So the plus 6 is distributed to 2 iron atoms, so it has to be iron 3. Okay, now we represent the version using a Roman numeral. If it's iron 2, you write a 2. If it's iron 3, you write a Roman numeral 3. Okay? Now, the anion part, which is the second part of the compound, you always just end the name in "ide." You take the ion and then you change the ending to "ide." So, this is nitrogen. In our example compound, this is nitrogen. Nitrogen becomes nitride. See, IDE, nitrogen, nitride. Then over here, this one is oxygen, right? This is oxygen. So that's very easy. Oxygen becomes oxide. So sulfur will become sulfide, fluorine will become fluoride, etc. See, over here, fluorine will become fluoride, chlorine became chloride, bromine becomes bromide, iodine becomes iodide, oxygen became oxide, sulfur becomes sulfide, nitrogen becomes nitride, and phosphorus became phosphide. Okay, very easy, just change the ending to "ide." So these are all elements that are found in the front of the periodic table. Okay, the anions, these are all on the periodic table itself. Okay, now let's try to name these. I'm going to do all the cations first and then I'll do the anions, okay? This is Na, that's just going to be sodium. Then this is Li, that's just going to be lithium. All you have to do is write the name of the element. This is Sr, that's strontium. And this is Al, that's just going to be aluminum. And then we take the anions, these are our anions, we just change them into "ide." Nitrogen becomes nitride, oxygen becomes oxide, fluorine becomes fluoride, and sulfur becomes sulfide. Very easy. Look at that. You know how to name basic ionic compounds now, okay? The cation stays the same. This is your cation. It's the same as the element name. And the anion ends with "ide." Anion ends with "ide." That's for elements, okay? So if you find the element itself, the anion will end in "ide." I'm stressing the fact that it's for elements because we're going to change it in just a second, okay? Now, these are polyatomic ions. There are certain ions called polyatomic ions, and the ones that have different endings. Those are the polyatomic ions. Let me tell you where to find them. On your periodic table, when you flip to the back and you scroll down or just look at the bottom table, these are your polyatomic ions, okay? Polyatomic, meaning many atoms. Poly means many, right? Mono means one, poly means many. So most of your polyatomics are anions, meaning they have minus charges. This is minus 3, this is minus 2, this is minus 1. Okay? There is one cation, that's a polyatomic cation, and that's right over here. This is your polyatomic cation. Okay? This one is the only polyatomic cation that you have to deal with. So I would make a note on your periodic tables that this is polyatomic and put a star here. It's always something that people miss. Okay? Now, look at how they are polyatomic. You have many elements together. They form one unit, and that unit has a charge of -1. So to make this easy for you guys, to make this so that it represents a unit, every time you take something from here, you have to put it into parentheses. Okay? Here's what I mean by that. Here's acetate. Acetate is C2H3O2. That means acetate is made up of 2 carbons, 3 hydrogens, and 2 oxygens. We're going to put that in parentheses, and on the outside of the parentheses, we're going to write the charge of acetate as -1, saying that everything inside the parentheses is what has the -1 charge. So this is how you will write polyatomic ions. You're going to put parentheses, and you're going to write the charge of the ion outside. So if I take something like this, it's going to be PO3 parentheses and then -3 on the outside. Here's the rule about polyatomic ions. You never touch the subscripts. Never change or touch the subscripts. You cannot. Okay, the polyatomic, I'm missing an R here somewhere. Polyatomic ions are the formula that has been given to you. You cannot touch them. You can't say that ClO is just ClO4 is ClO. If you drop this 4, it becomes this one, hypochlorite. It's only when the 4 is there that it's perchlorate. Okay, I'll just magnify it so you can see. ClO4 has a -1 charge, so does ClO, but the way they behave in a compound is slightly different. So because of that, you cannot touch any subscripts in the compounds. You're just using them to balance. Do not touch anything. You have to write the whole formula of the polyatomic anion, and then you can balance your compound. Okay, so polyatomic ions are ions made up of more than one atom with an overall charge. Okay, I don't like this. I like to write the ion charge on the outside. So it should be -2, -2, and then -1. Okay, on the outside. You never change the subscript, and you use parentheses when you're going to write ionic formulas. Okay, so here's a compound, iron 2 nitrate, right? We know that this ion is going to be Fe2 plus because the Roman numeral tells you the charge. Ion 2 is Fe2 plus, ion 3 is Fe3 plus, etc. Then you're going to look at this formula. This is not any element you can find in your periodic table, right? Nitrogen is nitride. You can't ever find nitrate on the periodic table. Okay, most of your polyatomic anions end in ATE and ITE. So if you encounter these two endings, that means you're looking at the back of the periodic table. See, acetate, 8, 8, 8, ite, ite, 8, 8. Hydroxide is one of the only ones that end in ide, but you know for a fact that there is no element called hydroxide. Okay, this one is 8. Cyanide is just another one that ends in ide, but again, cyanide is made up of 2 different elements. There's no single element called cyanide. Okay, then permanganate, 8, 8, 8, 8, ite, 8. Majority of them end in ate and ite. So peroxide, hydroxide, and cyanide. Those are the three that end in IDE. So you should remember those as being exceptions and check those in the back of the periodic table. But look, every single other one ends in ATE or ITE. So if you encounter that ATE, you're going to directly flip to the back of your periodic table, find that, and then just write the formula. So look, let's find nitrate. That's what we're dealing with here. Nitrate. Make sure you pick the correct one because there's also nitrite and it's easy to get confused. Here is nitrate, NO3. Here's what I'm going to do. Just like we did the other compounds, I'm going to say NO3 and it has a -1 charge. Now, easy peasy balancing, right? I have a +2 here and a -1 here. I need to bring this to a -2. So I multiply this by 2. That gives me a -2. So +2 -2 cancel out, and here's my compound. Fe parentheses NO3 close parentheses, two of them. I need 2 units of nitrate to balance out the 1 unit of Fe. So if I draw the compound out, it would look like this. Here's iron with a 2 plus charge. In these are nitrates, and each of them would have a -1 charge. The +2 and the -2 will cancel out, and you have your compound. Okay, that's what it means when I put a 2 outside the parentheses. Here's the most common mistake. People will write like this. They'll just forget the subscript next to oxygen, and that's very wrong. You cannot just eliminate part of the formula of nitrate. Nitrate must have 3 oxygens for it to be nitrate. Okay, if it's not 3 oxygens, then it's nothing. Look, these are what the units look like. Here is the polyatomic cation ammonium. It has 1 nitrogen and 4 hydrogens attached to it. If you remove even one of the hydrogens, if you change the subscript, it's no longer the ammonium cation. Okay, here's your nitrate ion, N with O, O, O. If you take the oxygens out, then it's nothing. Okay, that's not nitrate anymore. So we are balancing them as units. Okay, units have a charge. This unit has a charge. This unit has a charge. Here's sulfate. This is sulfur with O, 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 4 oxygens. And this entire unit has a -2 charge. And here's phosphate. It's PO, O, O. This entire unit has a -3 charge. Okay, we're balancing units, but you can multiply the units by like whatever number you need. You can say I need 3 of these units to balance out a charge, etc. Okay, so for example, if I have aluminum, let's say aluminum phosphide. Remember, phosphorus becomes phosphide. Oh no, not phosphide, I want to use phosphate. Aluminum phosphate. Okay, since it ends in ATE, I know I'm talking about something from the back of the periodic table. Aluminum is in group 13, so has a +3 charge. Phosphate's formula is PO4, 4 oxygens, with a -3 charge. So +3 -3 balance out, and you get AlPO4. Put the unit inside parentheses. 1-to-1 ratio. This one is +3, this one is -3, they cancel out, and you get your neutral compound. Okay? Now, here's what you need to be able to do with polyatomic ions. You need to be able to sight recognize when you look at a compound. If there are 3 or more element symbols, that means it is polyatomic. Here's your first element symbol, here's a second one, here's a third one. If there are 3 or more element symbols in the compound, you have a polyatomic ion. Here's another way to recognize it. It'll be inside parentheses. So anytime you see parentheses, you know that it's a polyatomic. So please don't make up names. This is the main problem. Do not make up names for these compounds. Okay, I cannot stress this enough. It happens every year. Please do not make up names. You don't need to, because all you have to do is read the back of your periodic table. So Imagine if I gave you this compound, Na2CO3. Sodium is just sodium. Remember, cation is just the name of the cation, sodium. You don't pay attention to any of the numbers. You just write the name of the element, sodium. Because anytime someone tells you that it's sodium carbonate, everyone knows that sodium has a plus one charge. Everyone knows the charge of carbonate. They assume that it's made with the ratio that balances out the charges. Okay, so all you have to write is the name of the element, sodium. Then your eyes should see, oh look, this compound has parentheses. Your brain should tell you, oh, parentheses equals polyatomic ion. Let me check the back of my periodic table. You flip to the back, you find CO3. You look through your entire ions. It'll be easier the more you get used to it. And you see, oh, look, CO3 with a -2 charge. The name of that ion is carbonate. So all you have to write is, okay, this compound is sodium carbonate. That's it. Okay, this one, you see that this is Ba, so you write barium. And then you see parentheses. Your eyes should say, look, there are parentheses. Your brain should tell you, oh, look, it's a polyatomic anion. Where do I find polyatomic anions? On the back of my periodic table. So I'm going to find C2H3O2. The name of that is acetate. Do I make up a name? No. I just look and I write the name acetate. Done. Okay, that's it. That's naming, and these are forming, same thing. Okay, so let's practice doing both now. This is going to be writing the formulas, and the three examples on the right is writing the names. Okay, so first thing, potassium. The symbol for potassium from your periodic table is K. Here is potassium. Potassium is in group 1, therefore has a +1 charge. So I am going to write K +1. Then I note that the next one is chlorate. If it ends in ATE, I know it's a polyatomic ion because all ions from the front of the periodic table, meaning your monoatomic ions, end in IDE. If it said chloride, then I would just look at group 17. But because it says chlorate, I look at the back of my periodic table. I go down to this table and I try to find chlorate. Here is chlorate. Chlorate. ClO3 with a -1 charge. So that's what I'm going to write. ClO3 inside parentheses with a -1 charge. Now, I know +1 -1 cancel out. So here's my actual compound. KClO3 with parentheses around the ClO3. That's it. Balance out. +1 -1. The charges cancel out. There's your compound. Okay. The next one. I read magnesium. I find magnesium on the periodic table. Magnesium, Mg, charge +2. So I write Mg +2. I read the word nitrate. It ends in ATE. It's not nitride, that is nitrogen, from the front of the periodic table. It's nitrate, a polyatomic ion from the back of the periodic table. So I find nitrate. Here is nitrate. NO3 with a -1 charge. So NO3, let's use the same colors. NO3 with a -1 charge. Oh, look, I have a +2 and a -1. That means I need to multiply nitrate by 2. 2 times the 1 gives me NO3 2. So here's my balanced compound, Mg parentheses NO3. Make sure to write the full formula NO3. Then my multiple becomes my subscript outside the parentheses, indicating that I need 2 units of nitrate to balance out my 1 unit of magnesium. The next one, cesium. I look at the front of my periodic table. I find cesium. Cesium is in group 1 with a +1 charge. So Cs +1. Okay. Phosphate, not phosphide, phosphate. Phosphate is a polyatomic anion. I know because it ends in ATE. I look at the back of my periodic table, I find phosphate. Here is phosphate, PO4 with a minus 3 charge, phosphate. I write phosphate, PO4 with a minus 3 charge. Oh, look, there's a plus 1 on cesium, minus 3 on phosphate. That means I have to multiply my cesium by 3. That means cesium's multiple becomes its subscript, cesium 3 parentheses PO4, don't forget the 4, inside the parentheses all the numbers have to be written exactly as they are. CS3PO4 is my formula. Okay, now let's learn how to name or practice how to name. Na. I know that Na is sodium. The cation name I'm just going to write as is. Then I see Br. Br is bromine. Bromine becomes bromide, end in IDE. So bromine becomes bromide. I write bromide. IDE. Anything from the front of the periodic table. Bromine is in group 17 from the front of the periodic table. Front of the periodic table will end in IDE. Okay? Next, Li. I know that that's lithium. I write lithium, no changes to the name. Then I notice that there are parentheses. Parentheses, my brain tells me, is a polyatomic ion. So let me find out on the back of the periodic table what CO3 is. CO3 is right here. It is carbonate. So all I have to do is look at CO3 and write carbonate. And I am done. Nothing, no fancy things to do, just write carbonate. Then the next one is Fe. Fe is iron. But wait, my brain tells me that iron is a transition metal from the front of the periodic table, and that indicates that there are two versions of iron. There can be iron 3 or iron 2. So I have to figure out what iron it is. How do I do that? You're patient, you put parentheses for the Roman numeral, then you read what this is. You leave it blank. ClO3, it's inside parentheses. That indicates it's a polyatomic ion. I'll try to find where ClO3 is. Here is ClO3. ClO3 is right here. The name is chlorate. And I also noticed that ClO3 has a minus 1 charge. So I go back. I first write the name chlorate. Chlorate. I know it's chlorate because ClO3 is chlorate. Now, I know chlorate has a minus 1 charge. Minus 1 times 3 gives me a total of a minus 3. So, I look at iron. Iron has nothing next to it, no number next to it, which means there's just one iron. So, what charge can that one iron be to balance out the negative 3 from the 3 chlorates? Negative 1 times 3 is negative 3, so iron has to be plus 3 to balance out that charge. So this is going to be iron 3. If that wasn't clear, just draw it out. I have 3 chlorate ions, right? These are my 3 chlorate ions, ClO3, ClO3, ClO3. Each of them have a minus 1 charge. So minus 1, minus 1, minus 1, we get a minus 3 total. Okay? How many ions are there? There's only one ion. So what does iron have to be to balance out that plus 3? Iron has to be plus 3. So that is why it is iron 3. It's not iron 2 because if it was iron 2, it couldn't balance out with the 3 chlorate ions. Okay? So that's how you name and form compounds. If you get confused anytime, please pause, go back and rewatch it and do it together with me. Okay? That is the beauty of having a video. All right? So I'll tell you what work you're supposed to do after you watch the video in a second.